Hi everyone, welcome to our video on probability distributions. So a probability distribution is a random, or let's read it, a random variable is a function that assigns a real number to each outcome of an experiment. A probability distribution is a table that lists the possible values of a random variable together with the corresponding probabilities. So let's show how we can make these. So here we've got, in this first example, it says find the probability distribution for the random variable x having the probability function shown in the graph. So we don't know what this random variable is in this problem, but what they mean by this in some of this case, so I'm just going to do an abstract example in words. So it assigns a real number to each outcome of an experiment. Okay, so say there's an experiment where they're taking a survey and they're, I don't know, counting the number of people with different colored types of hair or different colored types of eyes. Let's do that, different colored types of eyes. And maybe they assign the value of 1 for like one for green eyes, and then maybe they assign the value for 2 for like blue eyes, and they assign the value of 3 for brown eyes. So something like that. So this abstract case wouldn't really make sense for like real purposes, but I mean they do stuff like this sometimes with stats and probability to kind of manipulate, I don't know, some type of result that they're looking for. So anyway, so all they're doing is just assigning numbers to some outcome. Here, they're on this example, they have assigned 1, 2, 3, 4, 5. And then here are the probabilities. So this shows it as a graph. However, what we want to do is make a table. So a probability distribution is a table. Usually it's shown something like this, where we have x right here, and then the probability of x down below. And then our x, so these are the outcomes. For this problem, it's only 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And then the probabilities are the y-axis coordinates that match up to the heights of these bars. So 0.1, 0.2, 0.4, and then 4 is back to 0.2, and 5 is back to 0.1. And if we wanted to, I mean, we can make it even more like a table, just like that, and maybe even create it so it's bordered all the way around. Okay, so it's something like this. Okay, so it's a little prettier this way. Okay, anyway, so these are our random variable outcomes, some value for those outcomes, and then below are the probabilities. Notice that all these probabilities should add up to be 1, so the sum of this should be 1. As long as they're showing all of the probabilities. Sometimes they might abbreviate a table for certain purposes, but here it does add up to 1 if we do add up all those probabilities. Okay, so that, let me write it as the sum is 1. Okay, since my number 1 looked kind of whack. All right, anyway, so that's how we make these. Okay, so this was a nice one because it just was really a convert into different visual. So we can go back and forth between these as well. So maybe they give us the probability distribution and we can make this graph. Okay, so but this table's a little better for us for what we'll use with it in expected value. So that's the next part that we'll eventually see. Okay, so let's also find another one where it's a little trickier. So on this example, it says 3 cards from a well-shuffled deck are drawn with replacement. Now that's weird for cards, but they're telling us to do that. So that means we're drawing a card, looking at it, and then putting it back into the deck. Okay, so that's weird. Usually when we play cards, we don't do that, but whatever. All right, so it says the number of hearts is noted. Prepare a probability distribution for the number of hearts drawn. All right, so to find a probability distribution, let's go ahead and leave ourselves some space. I'm going to kind of start to put our answer down here. Okay, so x is the number of hearts in this problem that we would draw. Number of hearts that could be drawn. And then we'll have our probability of those happening. Okay, so if we're drawing hearts, it says 3 cards are drawn. Well, if we're looking for hearts and we draw cards, well, I mean, there is a chance we get 0 hearts. There is a chance we get 1 heart. There's a chance we get 2 hearts. And then there's a chance that we would get all 3 being hearts. Okay, so this is the number of hearts that we might be able to draw when shuffling through a deck and taking out 3 cards. Okay, but it is with replacement. Either way, let's figure out how to get this prop. So the next step in this problem is really get these probabilities. Okay, so I put that down below because my space really is, this is a multiple event scenario where I'm looking at hearts or not hearts. So I'm drawing a tree diagram to help me with those probabilities. So this is like the first card being drawn. And then from there, we can, let's go ahead and set up all of it with the H and not H. So then I'm going to draw a second card. And remember, it starts from the end of each of those on our first card draw. So heart and not heart. So I'm using the complement. So H is heart. H with the little apostrophe is not hearts. Okay, so that's the second card being drawn. And then one more card is drawn. Third card. And we'll set up our table, our tree diagram. Heart, not heart, heart. Oops, going too fast. That's also just heart. Keep the pattern going. And then it's not heart, heart, not heart, heart, and not heart. Okay, so there's the three different cards being drawn. And it is with replacement. Okay, so that means, so for some vocabulary, that means these will be independent because the deck is not changing. So the card gets drawn, it gets looked at, but then it's put right back in. Okay, so now we're just thinking, well, what's the probability of drawing a heart? Well, there are 13 hearts in a deck, and there's 52 cards in a deck, which means the probability of not drawing a heart would be there's 39 non-hearts out of 52. Okay, and then moving on. Well, because it is independent of each other, so since we put the card right back in, this next probability is also going to be 13 out of 52. So all of the hearts probabilities are actually 13 out of 52. But since it's also, let's add one other thing, since 13 out of 52 does reduce to 1/4, let's go ahead and write 1/4 for all of the ones that have just heart in it. 1/4 for all of those kind of top branches. And then because 39 out of 52 would be the probability for all the non-hearts, we could write that in there. But again, let's go, I'm going to even cross this out and just say, let's just say that this is 1/4. So it's all 1/4 and easy to look at. The 39 out of 52, that would be 3/4. And that's all of the non-hearts. So again, just to save a little space, that's what's kind of nice about this problem. And remember, it can be a little tricky. Hopefully write these big enough so you can fit all that information in. Okay, and then right here, it's looking at, so all of these probabilities. So this is the probability of all three hearts. And then this is the probability, so we'll follow the branches. So heart, heart, not a heart. And then this next one is heart, not a heart. And then a heart. The fourth one is heart, not a heart, not a heart. The fifth one down here is not a heart, and then 2 hearts. Oops, I did the wrong symbol there, sorry. So not a heart, and then 2 hearts. Getting down to the next one, we have not a heart, so probability of not a heart. And then a heart, not a heart. And then 2 more. The probability of not a heart, and a heart. And then finally, the probability of all 3 not being hearts. Okay, and so this is where we would multiply these probabilities out. Okay, so we have 1/4, 1/4, 1/4 would multiply. So I'm just going to use my calculator. So, and I guess we'll show the first one. So remember, it's following the branches probabilities. So 1/4 times 1/4 times 1/4 would be this one. And from there, so it's probably easiest to use a decimal. So let's go ahead and change it to a decimal. So 1 divided by 4 times 1 divided by 4 times 1 divided by 4 gives us that 0.015625. Okay, so I'm going to move that over. 0.15625. And then our next one is the probability of 1/4 of, well, of a heart, and a not a heart, which would be 1/4 times 1/4 times 3/4. And then, well, we would need to multiply that. Okay, so another form of the calculator. So 1/4, let's 1/4 is 0.25 times 0.25 times 3/4 gives us that 0.046875. Okay, so a little tedious getting these. Notice that this one would be 1/4 times 3/4 times 1/4. That one we actually already have. It's right above. Okay, because it's just a different order of multiplying, but it is the same deal. And actually, if we skip one, just to write our fraction in, that would be the 3/4 times 1/4 times 1/4, which is the same multiplication, just in a different order, but that's still the same decimal. Okay, so we can speed some of it a little up. Okay, this one that I skipped, though, would be 1/4 times 3/4 times 3/4. Okay, because it's following the branches. So 1/4 and then 3/4 and then 3/4. The heart, not a heart, not a heart. And then from there, well, we can multiply. Okay, so that would be 1/4, so 0.25 times 0.75 times 0.75 gives us that 0.140625. Okay, and then these next two would actually be that same decimal. Let's go ahead and just write out the decimal to save a little bit of time on it. And then the last one would be 3/4 times 3/4 times 3/4. Okay, so 0.75 times 0.75 times 0.75 gives us 0.421875. Okay, so there they all are. You might need to round some of these depending on the problem, so I kept them unrounded. I wrote the whole thing, so they're all to 6 decimals. All right, so now I need to fill this table in. I might not have given myself enough room, so I'll write a little small. I think it's actually going to be okay. Okay, so the probabilities go in. Okay, so this 0, let's use some colors. We'll color code it. So this is saying this right here, that I'm going to mark in purple. This is the probability that we get 0 hearts. So P of 0 would be the probability of 0 hearts. Well, looking at our tree diagram, that's this number. This is the only time that we don't get any hearts. So 0.421875. Okay, so that's that probability. And then the next one, let's mark it in blue. So this would be, so this is P of 1. So it's like making connection with the table. So the 1 value is going into that X there. That's this P of 1. But this is the probability of getting 1 heart. Okay, so the probability of getting 1 heart, well, that's this one. That's also this one. So I'm marking them in the blue. So I'm just finding where there's just 1 heart. And then that one. So the 3 that I marked in blue would be the probability of 1 heart. And then, well, we would add these together to get the official final probability for that table. Okay, so notice that they're all the same. So 0.140625, really just times 3 would do it. And it gives us 0.421875. So that's a coincidence that it's the same number as our first answer. But that just happened to how it worked on this one. 421,875. So the probability of getting 1 heart is actually the same as probability of getting 0 hearts. Then the probability of getting 2 hearts, let's mark that in green. Okay, so this is the probability of 2 hearts. Okay, so the probability of 2 hearts, well, looking at my tree diagram, there's where 2 hearts occur. Here's where 2 hearts occur, and here's where 2 hearts occur. So it's this one. Let's go ahead and do like a, whoop. There we go. Okay, so that's how I'm going to mark it. Okay, so, but you maybe can see it all. So it's these 3. So I'm doing the little spiral type thing. Okay, so it's these 3, and again, those would get added. So 0.046,875, and there are 3 of them, so I'm just going to do times 3, which gives us 0.140625. Oops, I wrote that 0, I shouldn't have. 140625. Okay, so that's the probability of getting exactly 2 hearts. And then this last one, let's go ahead and mark it. We'll do it in orange right here. I'm going to just do like a cross or a plus type symbol. This is the one time where we got all 3 hearts. Okay, so that is the 0.015625. There we go. Okay, so then I can't mark it. That's the probability of getting 3 hearts. There we go. Okay, so this is the table. So this is the probability distribution. So this, I didn't mark this. This is the probability of X hearts. And we can see it kind of, I think, better down there. Let me box it like this. So that is our probability distribution. So this one is kind of as nasty as it gets, where we had to find all these. Often they're a little nicer to us, but thought it was good for the challenge problem on it early. Okay, anyway, so that's one of the parts of this whole section here. The next is using them. So we get these, and then we use them to find this expected value. So that's what the next video will be on. So right now, all we did was just get it. Okay, so this is maybe abstract for now. We'll use it in the next video. Okay, so but we will pause. Okay, so thanks for watching. If you do have questions, let me know. Otherwise, I'll see you again soon.